The resulting image, which represents spectral classes, was created without much involvement. Next steps involve making sense of the result. Generally, some of the spectral classes might make sense, but others are likely a mix of cover types. Normally, some field work could be conducted or use other data to help make some determinations in land cover types. In addition, some manual processes to change groups of pixels can be expected. The interpretation and revision of the results are often involved and can easily take weeks or months of time, not just days. So, look at the obvious. Water, oftentimes, is represented as a single class or maybe two classes. To make it easier for us to understand what the classes are representing, let's add a color composite of the TM-SAC sub to the map display for comparison purposes. So I'm going to click Raster, Manage Colors, Create RGB, or r.composite. There we go. For red, I'm going to choose TM-SAC sub 3. For green, I'm going to choose TM-SAC sub 2. And for blue, I'm going to choose TM-SAC sub 1. I'm going to make sure Add Created Maps to the Layer Tree is checked. And I'm going to click Run to run the tool. Oops, and it's asking for the name of the output. I forgot to do that. That is going to be TM-SAC sub RGB. Now I can click Run. There we go. If no errors are shown in the command output, which none are shown here, I'm going to click Close to close the tool. I'm going to view the map display, and note that I can see the true color composite. So let's have it draw underneath the classification image. In the Layer Manager, I'm going to drag TM-SAC sub unsoup class above the TM-SAC sub RGB, and release the mouse key. I should now see the classified image in the map display, and I do. So I'm going to toggle the visibility of the classified image by checking and unchecking the checkbox next to the layer name in the Layer Manager. While toggling the visibility, determine which color represents the water features. Now that we've identified that the color yellow in our example represents water, let's determine which class in the raster represents water. So in the Layer Manager, I'm going to select the TM-SAC sub unsoup class, and then in the map display, I'm going to click the Query Raster Vector Maps button. I'm going to click on a cell in the map display that represents the water feature. So I'm going to click on a yellow cell here. And it's going to perform a query. And on the command console here in the Layer Manager, this displays the results of our query. So in our case here, we can see that class 1 represents water features. Now that we know that class 1 represents water features, let's only apply color to that class to easily see where the water is identified. To do that, I'm going to click Raster, Manage Colors, Color Tables, which is r.colors. This will open the Color Tables tool. Click on the Manual tab and read the following sections: Name, Description, which is down here, and Examples. So that's all these down here. And the short of it is that a color table modifies the color table associated with the raster map layer and allows us to assign different colors to different classes. So I'm going to click the Required tab, and the name of the input raster map, I'm going to set the TM-SAC sub unsoup class, which is already selected. I'm going to click the Colors tab, and in the Or Enter Values Interactively box, I'm going to enter 1 space yellow and then default gray. And so that assigns the class 1, you can see over here to the left, the color of yellow, and then the default, which means all other values, class values, that will be gray. I'm going to click Run to set the color table. I'm going to click Close, and now you can see that the water is isolated. Most of the spectral class 1 falls along the river and is likely correct. However, some pixels in class 1 fall on agriculture fields in the southwest corner, as you can see here. When an image analyst is evaluating and trying to determine the land cover types in an unsupervised classification, it can be useful to label the spectral classes to prospective land cover types. Now note, most of the spectral classes will not represent a single land cover class. This is because a human creates a land cover classification scheme, whereas the unsupervised classification is categorizing pixels into similar spectral groups, which may or may not relate to specific land cover types. Since the land cover types are not known when the unsupervised classification completes, additional work and investigation is required to refine the spectral classes into specific land cover types. To make a first attempt at determining the land cover types, the analyst can label possible land cover types for each spectral class. For spectral class 1, since this category seems to represent water cover types, the spectral class can be labeled water. And so now that we know that class 1 represents water, let's recolorize all classes, then change the class label from 1 to water. And so I'm going to reopen the r.color tool. Here we go. And I'm going to go to the colors and make sure that the or enter values interactively is empty. And for the type of color table, I'm going to choose rainbow. There we go. And this is going to revert the classified image back to its original colors. So I'm going to click Run and then click Close. Now I'm going to click Raster, change category values and labels, and then Reclassify, r.reclass. Click on the Manual tab and read the manual to understand what it does. The short of it is that it reclassifies a raster map based on category values that we provide. We're now going to go back to the Required tab, and for the raster map to be reclassified, this is tm-sacsub unsup class. The name for the output raster map is going to be tm-sacsub unsup class reclass, and add created maps into layer tree should be checked. Now I'm going to click on the Optional tab, and I'm going to enter these values interactively. Oops, let's see here. Sorry, it's still on the Required tab. I'm going to be 1 space equals space 1, and then star, space water, and then star space equals star. I'm going to click Run to reclassify the raster. Then I'm going to click Close to close the tool. So you probably noticed that the newly added reclassified layer looks exactly the same as the original raster, and that's normal. What has changed is the class label. So let's see what I actually changed here. So in the Layer Manager in the Map Layers tab, I'm going to make sure that the reclass is selected. I'm then going to choose the Query Raster Vector Maps button, and I'm going to click on a water feature cell. Now we're going to inspect the command console to see what was returned, and notice now that instead of class 1, 1 is now specified as water. Reclassifying the raster map makes it more intuitive when trying to understand or query the layer in future operations. The other classes can be assigned in a similar fashion. So it can be time consuming to specify the names for each spectral classes, and it takes some serious review and visual analysis and consultation of ancillary or reference data and often field work. To get more practice, work on some of the other classes using the same methods to label the spectral classes at this point. No additional ancillary information exists to continue this exercise. So students not familiar with the Sacramento area can use Google Maps or Google Earth to review high-resolution image data that can assist in assigning spectral classes to the prospective land cover types.